Today, we are going to talk about electron configurations. And I'm going to go ahead and just make a prediction. Probably about 60% of you are going to go, makes sense. The other 40 are going to go, what just happened? It's okay. It's normal. Been doing this for 18 years. It's not my first horse and pony ride here. All right, but one thing that we need to realize, most importantly, this statement right here, only 2 electrons can occupy the same orbital. No more than 2. You can have 0, you could have 1, but no more than 2 electrons per orbital. Okay? It's really important. Also, keep in mind that the electrons must have opposite spins, and I used the magnet the other day, so one has to be spinning up, the other would be spinning down. They both can't be spinning up, or they both can't be spinning down. That's the Pauli exclusion principle. We already talked about that, I think, the last time. I think there's your one blank opposite. Here is an example of what we're going to do today. Okay, now when you look at this, what I have, or probably the better way to think about the configurations, when you write the symbol, think of that as the nucleus. So I've got the nucleus, and I'm starting to put electrons closest to the nucleus first. If I were writing the configuration for hydrogen, I would never place the electron as far away as possible. So instead of having that one there, I placed 1 electron out there. What's going to happen is that electron is actually going to move in until it occupies the lowest energy level. Okay? So that's why we always fill up the orbitals closest to the nucleus first before we fill up the ones that are farther out. Okay? Now, after tomorrow, you'll be pros at this. Okay? You hope. Yeah, no. Is that, you're calling that an L? That is actually an arrow, a half arrow. One going up, the other going down.
So why doesn't on oxygen the other one go to the... They're both ups.
Yeah, and if you wanted to say that one was down and that one was up, I don't care. It really doesn't matter. I always write my first electron up, but if you want to write them down or alternate, I don't care. Just as long as when you finish that they're opposite spins. Yeah, that's a good question. This pattern or this sequence right here, you don't need to memorize, but you'll know it. Okay? So don't freak out and go, whoa, what is that? Because after we get done with the periodic table today, looking at the periodic table, this is the sequence. Also, this sequence down here, okay, is the same sequence that I have. So that is the same sequence that's representing that image above. Okay? Not something that you need to memorize, so I don't want you to go, oh my gosh, how do I do 1s2, 2s2, 2s, whatever. Don't worry about it. Okay? The periodic table is going to be at your disposal. Here are, were there any blanks up to that point that I skipped over? Okay. Here are the other 2 rules when writing electron configurations. You don't have to memorize these rules. Just know them. Doesn't that make sense? So you don't have to explain, what is Hund's rule? What is the all-ball principle? What is the Pauli exclusion principle? It'll make sense once we start doing electron configurations. But Hund simply states, with 2 or more orbitals, always drop 1 electron in each orbital first. And I'll give you a little creepy story to go along with that. All right? Not like spooky or scary. Creepy. No, creepy. Like really creepy. And then the all-ball principle states that we're always going to fill up the lowest energy level orbitals first before we fill up the higher energy level orbitals. So again, these are not rules that you have to memorize or regurgitate. Just know them for when we write the configurations. All right. Let's do some practice here. But before we do that, your periodic table. If you go to the content library, copy the periodic table over to this topic. Give you a second here. So again, go to the content library. And I put it in there, but I forgot to put it in your notes, which was irresponsible of me. So copy that and place it in your notes, because you're going to want to have that periodic table with you. Okay. So periodic table, I'm going to blow that up. And this is where you get to use your colors and all that fun stuff. make notes on this periodic table. If you have your printed one, you can also write on that as well. But at least what's nice about this is you always have this. All right, first of all, helium for our electron configurations is in the wrong spot. It is a noble gas. It is a noble gas. But really, it should be here for our electron configurations. Okay. So the first thing I want you to do is write helium on the left. Okay. Don't scratch that one out because we need it for other things, but write it here. What that means is here, these first two columns, and I want you to get some color, whatever color makes you happy. The first two columns, this represents the s orbitals. Okay? The first two columns represent the s orbitals. Guys, I want you to be drawing on the periodic table right now. Okay? Don't talk. You can talk later. So the first two columns represent the s orbitals. These columns right here, excluding helium, represent the p orbitals. Okay, so from 3a to 8a, so the green area here represents your p orbitals. Okay, so the red is the s orbitals, the green is the p orbitals. The blue, so once we step down and before we step back up, this area right here, these represent the d orbitals. Okay. So red is S, green is P, blue is D, and I am only limited to 4 colors here since I'm not using the smartboard, or I'm sorry, the notebook. The 2 rows on the bottom, those are your F orbitals, which we will do very little with. I'll never test you on the F orbitals. Okay, so the bottom 2 rows are your F orbitals. So again, S orbitals, P orbitals, D orbitals, and the bottom 2 rows are your F orbitals. Now, I think this kind of got cut off over here, but these are the numbers. So like 1, 2, 3, 4, 5, 6, and 7. For S and P, orbitals, row number equals energy level. Okay. For S and P orbitals, so like there's the 1s orbitals, the 2s orbitals, the 3s orbitals, 4s, 5s, and so on. Over here, you'll notice that the p's start where? At what row? 2. Okay, so the p's start in a 2, so 2p, 3p, 4p, etc. Okay, the d's are actually 1 less. So it's in row 4, but this is a 3d orbital. It's in row 5, it's a 4d orbital. And I'll talk about why that is once we start doing the configurations. But for d orbitals, it equals row number minus 1. Okay. So if you're in row 4, minus 1, it's 3. And then the f orbitals are row number minus 2. So the F start in the 6th row, but it's the 4F orbitals. Okay. A lot of information on that periodic table right now. Okay. Whenever we do electron configurations, we always start right here, number 1. Okay. And when we do electron configurations, each element represents an electron, which is kind of cool. I'm going to leave all that on there. So let's look at our first practice problem. Okay. First one says diagram the electron configuration. So electron configuration. And there's 3 different ways I'm going to show you. Unfortunately, they get easier as we go along. I know. I'm sorry. Okay. So here's how we start off something like this. Okay. you'll notice that I'm giving the symbol, but I'm also giving the proton number or the atomic number. Because for these are neutral. What does neutral mean again? Yeah, no charge, or the number of electrons equals the number of protons. Okay. So when we finish, we better have 7 or electrons when we finish. All right. Also, let's do this. Remember that the sequence in which we'll fill them up go S, P, D, and F. And how many of each of these orbitals do we have? So in any given S orbital, you have 1. In the P's, we have 3. In the D's, we have 5. In the F's, we have 7. Okay. So make sure you know those numbers. So and if you look at the periodic table, when I look at the S orbitals, how many electrons are there? Quote unquote. If I go from here to here, 2. Okay. And remember, what's the maximum number of electrons that can occupy any one orbital? 2. So that right there represents one orbital. The P's, how many elements do we have across in a given row? 6. So 6 divided by 2 is 3. If I look at the D's, how many elements are there? 10. Very good. So 10 divided by 2 is 5. And then if you were to count the F's, 14. 14 divided by 2 is, there you go. So that's how we get our orbital numbers here. Okay? Because you can put 2 electrons in each orbital. Okay? All right, so we always start right up here with the hydrogen. So row 1, and what orbital is that? Row 1, what orbital is that? Row 1, start with, every energy level starts with a S orbital. Okay, so I'm going to write a dash down there. And the dash represents an orbital. So in the S's, how many dashes should I have? 1. Okay, and then what I'm going to do is I'm going to drop 1 electron in each of those. Okay, so I'm going to go, here, let's go red. So there's 1 electron, and there's my second electron. Now, the half arrow, 1 up, 1 down, represents opposite spin. If you like starting down and then going up, whatever, I don't care. Okay, just don't have the same directional spin. Okay, and now if we go back to our periodic table, we've dropped electrons in the first row. We've filled up the first row. So now we go to the second row. Okay, so we're going to go, I'm going to put a line right here just to separate it. So the second row, and what do we start every energy level with? An S orbital. So I'm going to go there. And how many dashes should I have for that S? 1. Okay. Then I go back and I said, okay, in the second row, how many electrons am I going to put in there? 2. Very good. So I'm going to go 1, 2. And if I were to stop right there, okay, I'm not looking at nitrogen. How many electrons do I have represented? 4. So if I were to ask you, okay, I have this configuration, what neutral element does this configuration currently represent for? Beryllium. Very good. So if you were to look at the periodic table, we'd say, oh, well, that has 4 protons. There's 4 electrons. That configuration right now represents for beryllium. But that's not where we're going. Okay. All right. So now, whoa, come back. Okay. So now that we filled up the S's in the 2, now we need to move across. And what are these again? What orbitals are these? P's. Very good. Okay. So we're going to go across and we're going to start to put electrons in the P's, but I need to represent it. How many dashes am I going to put there? 3. Very good. Because there are 3 orbitals for any given P. Yeah. Because it is in row 2. So remember that whatever row the S and the P's are in, so right there, that equals the energy level. So it's like reading a book. We're going to go right across when we get to the end here, then we're going to go down to the next row and continue on reading. Okay, good question. All right, so let's see here. So now, nitrogen, if I were to look at nitrogen on the periodic table, how many elements do I count in to get to nitrogen? 3. So that means I'm going to put 3 electrons in each. Now here's the thing. We want to place one electron in each orbital before we go and double up. Here's what we don't want to do. Okay, I'm going to move you over just for a second. I don't want to do this. Okay? Here's the really creepy story as to why. Okay, I have a brother and a sister, and my parents, when I lived with them, when I was a kid, they had their own bedroom. So I'm going to throw my brother out of the mix here. I'm just going to talk about my sister and I. Let's pretend that I lived in a 3-bedroom house. We actually had more bedrooms. But let's say that we did live in a 3-bedroom house. Mom and Dad stayed in one bedroom. Me and my sister stayed in another, and we had an empty bedroom. Does that seem normal? No. Electrons are exactly the same way. They want their own room. They don't want to have a creepy situation. Okay? The only time that it doesn't get creepy is when you have more kids than you have bedrooms. But if you have an option, I mean, there's nothing in that bedroom. It's empty. It's not even a den or filled up with workout equipment that nobody uses. It's just, yeah. Elements want their own room. Or I'm sorry, electrons want their own room if they can have it. So that's bad. That is creepy. Okay. So drop one electron in each orbital before you go back and double up. Okay. Hopefully that wasn't too traumatic for some of you. All right, let me ask you. How many electrons do I have represented right now? 7. How many should I have? 7. So I'm done. Very good.
Wait, so how do you know whether or not to add like
What do you mean? The only
like the first two, like it has one up and one down.
Good.
The third one it just has 3 up there.
Here, let me get that back. Okay. So if I had, say, oxygen instead of nitrogen, okay, now I would start to go and double up. Okay. Since I have
So
nitrogen,
because we found out that the number is 3 by counting to nitrogen to get 3, and there's 3 spaces, we have 3 up.
I love it.
Could it be 3 down arrows?
It could be 3 down arrows if that's what you like doing. Yeah. Or it could be 1 up, 1 down, 1 up, just as long as they're not in the same orbital. Yeah, I like that. All right, let's look at a more interesting one. Okay, calcium. So start off the same way. And how many protons does calcium have? 20, that's why it's there, 20. Okay. So we should, at the end, have how many electrons? 20. Very good. So when we go back, could you kill that window? I'm trying to find my buttons here. There we go. Perfect. Thank you. All right, so we start at the beginning. So what are we going to write? 1s, and then put 1 dash there. And how many electrons should go in there? 2. We're going to fill it up. We're trying to get to calcium right here. So it's in row 4, right? Okay, so we'll try to speed this up a little bit. So we'll drop 2 electrons in there. And then, dang it. So now I filled up the first row. Now I'm in the second row because, again, there's only the s orbital in the first row. So now I'm dropping 2 electrons here. So I now, 2s. And again, drop 2 electrons in there. Okay, go across. So now I filled up the 2s. Go across, which is what? Which orbitals? 2p, good. So 2p, and how many dashes should I have? 3. And how many electrons will we place in the 2p's? 6. We're going to fill it up. Okay, so we're going to calcium. So we're loading it up. I'm going to drop 1 in each. Then I'm going to go back and double up. Okay, drop 1 in each, and then go back and double up. Just coughing. All right. All right. So if I were to stop right here, what element am I representing for? Who has 10 protons? Neon.
Abby.
So if we were to stop, this is the electron configuration we would have for. Kate doesn't listen. I mean, come on. All right, so now we filled up the second row. Now we're ready for the third row. So what do we start with? 3, since we're in the third row, and always start with an s orbital.
Wait,
Yeah.
why don't you go past P?
Why? What? Say that
Why
again.
don't you go past P?
Why did I?
Why don't?
What do you mean past P?
Like, isn't there like other letters?
Well, once we fill up the P's, now we're ready to go back
Oh,
to the next row.
S.
Yeah. So once you fill up a row, now we got to go to the next row.
How would you ever get to the S?
Huh?
How would you ever get to the D or the S?
The D's or the F's?
Yeah.
I'll give an example.
Okay.
Let's do simple first. So how many electrons am I dropping in here in the third row? 2 of them. Good. So, let's do a different color there. So 2 there. Okay. Now that I filled up here, go across. How many, or what orbitals? It's the p orbital, but what number? 3. Very good. So it's a 3p, third row, p orbitals. How many dashes? 3. And how many electrons will I place in there? 6. Put all 6 in. Good. 1 up. Then double them up. And if I were to stop right there, what configuration do I have for? Okay. So argon. So now that we have, what row are we now in? And we're in the row that we're looking for, the elements in, so that's nice. 4s. So, and how many electrons? 2. Okay. Now, just to make sure, how many electrons do I have represented here? 20. Okay.
If you're like looking for boron,
Yeah.
and you got into the GP section, you still draw 3
Still,
lines.
yeah.
There's only 1.
Very good. So if we were doing boron,
You just bought 2 extra bedrooms for no one.
we built to expand. Yeah, you gotta have guest room.
2 yes.
You gotta have a workout room that you'll never use.
Wait, what do you mean?
He's asking about boron. Since boron is element number 5, okay, here. So we're going to fill up the 1s, the 2s. He was asking, since there's only 1 electron, do we still show those 3 dashes to represent the p's? Yes. There wouldn't be 1 dash. There's 3 because the p's have 3 orbitals. So represent the orbitals even though we're only putting 1 in. Okay. All right. This is called. This is called. This is called electron configurations. Let's take you on a journey to notation. No. Shh. Don't say that. Chemistry's not easy. Super easy. All right. So here I'm drawing nitrogen. Okay, same thing. And when we do notation, and it's nice, some of you may need to draw the configuration before you do the notation, or you'll get very good where you'll just be able to look at the periodic table and do it. But what do we start nitrogen off with? Here, let's go right back here. Where do we start? 1s, very good. And let me ask you, how many electrons were in that? 2. So it goes 1s, 2. Okay. Then once you fill up the first row, you go to the second row. We're now in what orbital? 2s. And how many electrons did we place in there? 2. So you write it. 2 there. Okay. And then we go across, and now we're in which orbitals? The p's. And for nitrogen, how many do we put in? 3. 1, 2, 3. Okay. So 2p3. Yeah.
Don't you do the configuration first and then you write it in notation?
You may, but if I just ask you for the notation, go right for the jugular. In other words, knowing that nitrogen is right here, you're going to be able to go, okay, it's right there. 1s, 1, 2, 2s, 1, 2, 2p, 1, 2, 3. Done. Okay. All right, so let's look at calcium. Okay, calcium. Okay. So again, where do we start? 1s. 1s what? 2. So let's go a different color. So 1s2. Then we fill up the first row. We go to the second row. 2s2. Then we go to the next. Go across. What is it? 2p6 because it's full. Okay, so now we've got the second row completely filled. Now we start in the third row. And again, we're going to calcium here. 3s2. And then go across. Now we're in 3p6 because we're filling it up because we're trying to get to the fourth row. And then we filled up the 3s. Now we're in the 4s. And since we're going to calcium, put 2 in there. Okay? That is notation. There's a third way. There is a third way of doing this. I cannot. Okay? Yeah. Hang on. Shh. Go now. Go ahead and write notes if you can, like on paper, because I don't want you to miss this. Yeah, I know. All right. Here's the last one that I'm going to show. It's called shorthand electron notation. Okay. So when we look at the periodic table, and let me clean some of this up. This is sloppy. Okay. So when we look at this, let me put that 3D back in there. That form. Okay. Yeah. What is what used for? The energy level? Yeah, the row is the energy level that we've used so far.
So like the energy level is 1, 2. All of that just means the row.
Correct. For the S and P orbitals, the row is equal to the energy level. For the D's, it's 1 less. I'm going to give an example here in a minute after I do the shorthand.
So that first row would be 3 on the D. I mean the
Right here, in the fourth row,
yeah, for the D.
it would be a 3D because it's row minus 1, wherever it is. Yeah, somewhere. Yeah, here, row minus 1. Got a lot of things right there. All right, so shorthand notation, here's how we do this. Okay? If it's shorthand notation, you go to the periodic table, you find the element. It's right there. What I want to do is I want to go up 1 row, and all the way to the right to the noble gas. Okay? Go up 1 row, all the way to the right to the noble gas. Okay? And once you have done that, then what noble gas did I have for that? Helium. You'll put helium in brackets. Now, unfortunately for any row 2 element, this isn't really a shorthand because what that represents is the 1s2. Okay? That's what that represents. And then you have to ask yourself, for the shorthand notation, what row is that element in that I'm looking for? What row is that element in that I'm looking for? 2. So we start with the S's in the row that it's in. So from here, we've already got this shorthand that represents 1s2. Not very much of a shorthand. Start in the second row, 2s2, and then what? 2p, 2p3. Okay. Now, that's kind of cheesy. Yeah.
So is like whenever you're going up and over to helium, is that just like making it shorter so you don't have to do the other stuff?
Beautiful.
I'm just standing right now.
It would be a lot more shorthand notation if you just put the last term.
No. So whenever you do notation, you have to put the S and everything preceding it in that row. You have to show that. And what we haven't talked about are what core electrons are and valence electrons. So it might make a little more sense when we do calcium. So calcium is right here. So what do? Go up one row, and what noble gas is that? Argon. So when we do calcium, okay, so we have calcium, and we'll put in brackets argon. In other words, even though we haven't talked about, whoa, I need to move that up. Sorry. I should have moved it up at the beginning. Here. Good night. All right. So, sorry. So we said argon, right? And what that represents, now listen, that represents all of this when you do argon, because it represents the filling up of the 1s orbital, the second energy level, and the third energy level, which in this case is rows 1, 2, and 3. And then we start in the same row that that element's in, which in this case is 4s. So 4s2. All right, Cameron, yeah. Shh, hang on. Slide all the way to the right to the noble gas. Okay. I want to do another example that's not in here, just to see how good you guys are. Okay. You say no, but you really mean yes. Not in chemistry. All right, so let's take a look at silver. Got to do silver. Got to do silver. Okay. And let's just go ahead and do the notation, then we'll do the shorthand notation. So, silver has how many protons? So 47. So, let's go fast. 1s, 2. There you go, now you're getting it. So 1s2, 2s, 2. 2p, 2p6. Then we're in the third row, 3s, 2. And we go across, 3p6, good. And now we're in the fourth row, 4s2, very good. And now we're starting to venture into the d's. It is 3 because now the D's are row minus 1. So the D's, and here's the reason why. So when we look at, and I'll put a 3D here for a second. Back here when we talked about the order, get that out of there. Okay, you have to fill up the s orbitals in an energy level first, then the p's, then the d's. If you said, okay, well I've got 4s, 4d, now 4p, you put the d's in front of the p's. So the way that we can get the d's to be in the third energy level is by putting it after 4s. Okay? So, whoop, go back. Where are you? Where'd you go? Here we go. So it'll be 3d, how many? How many elements are in here? 10, very good. And then from there, we're now into the 4p, good. 4p6, excellent. Getting ready to run out of room. So now I'm in the fifth row, which happens to be the same row as silver. So fifth row is 5s2, and then 4d9, excellent. 4d9. And that is the electron configuration for silver. Now quickly, what's the shorthand? Okay. Choose a different color. So you go up one row. Hold on, slow down, slow down. So silver is in row 5, so we represent all the orbitals filled up, which represents krypton here. So if I go silver 47, what do we say, krypton? Okay. Which again represents all of this. And then we go to the row that we're in, which is row 5. So 5s2, then what? 49. Cool. Okay. All right, one more thing. There's more. Now let me erase this mess here. Hopefully it'll get it. Well, we got most of it. All right. Yeah, this is the action-packed day. All right. I don't know. All right. I know nothing. Or the notes. All right. So now, let's see here. Get those blanks there while I erase the rest of this. All right. So here we're going to talk about ions, and we've talked about ions already. That if you gain electrons, you become more negative. If you lose electrons, you become more positive. So if I'm looking at, say, good old magnesium, and I will write the configuration here quickly. So magnesium is, and I'm going to draw it this way. So 1s, 2s, 2p, and let me separate these guys so you don't go crazy. And then 3s. That is the neutral configuration for magnesium. When magnesium has a +2 charge, what is it going to do? Lose 2 electrons. Where is it going to lose the 2? From here? No, it's going to lose them back here. So right now is the electron configuration for magnesium with a +2 charge. So the plus or the minus charge tells you how many electrons you're either going to gain or lose. Cool. And as another thing, as a real quick check, oops, sorry, let's go to periodic table. And as a real quick check, all of these will have the same electron configuration as one of those noble gases. So like if I look at magnesium and it loses 2 electrons, it'll have the same configuration as neon. Okay. Isn't that cool? So let's say that we have oxygen. Okay. I'm going to see if you guys are good here. See how good you are. If I'm looking at oxygen, how many electrons are in the p orbital for oxygen? 4. Okay. So what do you think is the most common charge for oxygen? Based on the there's 4 electrons here, and we need to get how many? 6. So how many more do we need to gain? So what's the charge on oxygen? Not positive. -2. Very good. So if I look at, say, let's look at a different one. Let's say we're looking at nitrogen. It has how many electrons in the p's? So it would be a -3 charge because it needs to gain 3 to have 6. It's just that easy, guys. So we'll talk about the charges there. But let's say that I'm looking at potassium. How many electrons does it have in the 4s orbital? 1. Does it want to gain 7 or lose 1? Lose 1. So what's the charge of potassium? +1. Actually, all of them are +1. All of these are +2. All of these are +3. All of these are -3, -2, -1. Okay. All right. So the homework for tonight is the 5.
It doesn't say whether or not you can use shorthand or long.
Do the arrows. Yeah. For the 5s, listen. For the 5s, show the first way, which is the arrows. Had your hand.